I swear to God that they did not know what I was doing when they make the title of their paper. They built this thing, and they presented it at the Sharks Workshop in Cologne earlier this year, called How to Break Desks for 8,090 euros, which was just, it kind of drove home one key point to me about the entire project. And this is the thing that I think is the most interesting revelation from the entire effort, is now a race to the bottom to figure out who can crack desks, right? It used to be a race to the top, meaning the way everybody used to look at the problem was how long did it take to crack desks. Now the issue is, oh, I can do it in 8 days. Oh, I can do it in 7 days. It's a race to the bottom. Cracking desks, a former federal and to some extent global encryption standard, is now a race to the bottom, right? And that's like hugely profound compared to where we were, years ago. So, in order to justify my continuous existence in this project, I will note that as of today, the screenshot from xv.com still shows that 8,090 euros is more than $10,000. But notably, they did, as you can kind of see in this picture, fabricate their own kind of modules here. But okay, so they call it Copacabana. They made like this constructed acronym out of a cost-optimized parallel code breaker, which is essentially exactly what Cheap Crac was. Cheap Crac was just a play off of Deep Crac, but yeah, cost-optimized, right? And this is the thing about hardware design. Unlike software, where you design for things like how fast does the UI respond, how many photos can iPhoto load, or things like that, you have constraints, but they're all very fungible. You can make trade-offs on CPU time versus memory access of things. In hardware, you have a lot of constraints as well, but a lot of times you can't really trade off quite as much, right? If you have an FPGA with so many logic gates or so many logic elements, you have only that many, right? So really, you have to optimize your design. So the part to mention here is that the constraints are low cost for both of us, for both Copacabana and Cheap Crac. The issue is do it really cheaply. Now, notably, they are people who actually know what they're doing. I am a complete dilettante at this. I admit it fully up front. About FPGAs and VHDL and digital logic, I've read from books and have learned from tinkering with stuff and failing. Whereas these people actually, went to university and have some amount of quasi-corporate infrastructure backing them up. It's not a lot, but they know what they're doing. I mean, they've actually learned it in a real setting. So what is their hardware? I want to talk about their hardware for a minute because it has a lot of relevance to Cheap Crac. Their hardware uses Xilinx Spartan 3 3S1000 FT256 FPGAs. This is the exact same FPGA that's on the board in the room, right? They're using the exact same model and the exact same mount, right? It is identical. Granted, they do mount 6 of them on a DIMM. So they built a little DIMM, and they mount 6 FPGAs per DIMM, and they just use the DIMM as a holder. This is a little module, basically. And so the way that they built it was they have these FPGA modules that they just slide into a backplane. And they built a backplane that has 20 DIMM slots, and little bits of controlling logic just to handle the bus. So their total setup is 120 FPGAs. So keep the numbers in mind. We went from 1,536 custom circuits, custom chips, to 120 FPGAs, right? Well, what do they get? The entire device, meaning all 20 slots, each with a module, each with 6 FPGAs, so 100 FPGAs running in parallel, does 48 billion keys per second. Okay. Each FPGA has 4 desk cores. So each little chip on their module is actually running 4 independent desk cores in parallel. Right? Their average exhaustive key space search is 8.7 days. Right? So we went from having it being able to be done in around 4 days, give or take, right? 4.5 days, with custom hardware and $250,000 to being $11,000 and essentially 8.7 days, right? And college students. This is roughly equivalent. They benchmarked a DES implementation that they had on hand, and they benchmark it that this is roughly equivalent to 22,865 Pentium 4 3 gigahertz cores doing nothing but cracking DES, roughly at around 2 million keys per second all day, right? They estimated, I think roughly they say their thing is 400 times faster, right? So if you had 22,865 Pentium 4s at 3 gigahertz cracking desks, you could get around the same average search time. And this is what their little device looks like. Basically they have some power, and then it's really just a complete, all it is essentially the same thing. They could build another one of these things and link them together, and they actually mentioned this. They have another port here, but they actually mentioned in their paper that you could have another module. They call one of these entire things with all the slots filled up is one Copacabana. So you could have another one of these linked to it by USB, and then decrease your search time by half, and so on and so forth. It's a really well-designed architecture. I haven't seen it in person. They presented it at a Sharks workshop in Cologne, and I haven't been to Cologne. So, now all of this made me really sad. I was really kind of hoping that it would be a neat project that I could get a lot of people into by virtue of talking at conferences like Toorcon, and also by virtue of passing around things and showing cool demos. I also understand that people don't really want to work on stuff that's been done before. So Deep Crac was done, but Deep Crac's a different thing, right? Deep Crac is a serious engineering effort done by unexpected parties. But replicating that as bedroom hackers would still be a neat project. Copacabana brings it closer to home, right? They do as well or better than Deep Crac for way, way less money. And it's so close to what I'm trying to do that it's almost like, well, why would I bother, right? Copacabana is really practical for desk cracking, and it's really practical for cracking in general, any kind of parallel problem you might have. So desk cracking, they mentioned in their paper some other issues regarding elliptical curve stuff and some bioinformatics algorithms they want to port to it. Essentially, they're just reprogrammable hardware, just like anything else. So anything that's parallelizable, you could use Copacabana to do cracking, which is the thing that they targeted first. Desk is an easy target. Again, it's a race to the bottom. So because of that, it's really practical for that kind of thing, but perhaps it's not as practical for other things. One is, it is also a custom fabrication job. So although they are using a commercial off-the-shelf FPGA, you have to make their DIMMs and plug them into their backplane and everything else. It lacks certain things. Cheap Crac as an effort, I think, is still worthwhile. It's a grassroots effort, and again, it's more about community than it's about cracking. Right? Cracking desks is so easy now that it's almost trivial, right? I mean, $11,000, if you were really interested in cracking desks, $11,000 is not hard to acquire, right? I mean, people with mob ties would sneeze $11,000 at you to be able to read email if it was encrypted with DES, right? Furthermore, it gets FPGAs into people's hands, which is really another huge point, right? It puts hardware in people's hands who, after they've decided that Cheap Crac bores them, or we succeed for some definition of succeed or whatever, they can go do something. And that can become a project. And then when they want help on that project, if they want to attract other people, oh, look, there's a community of people who already have the same exact dev board, who have experience working on the project, who have done something with it. So where is Cheap Crac today? Well, the board is being passed around, so you'll see it. It's an alpha, right? And I sort of told myself that regardless of the status of Cheap Crac at any given point, the first talk I gave about it would probably also be the last, only because I don't really like repeating the same talk every time I go to a con. But having said, I can attract people into it, or if people like it or think it's interesting, or even if somebody says, well, Cheap Crac is a neat idea, but maybe you really should target this other thing, that's totally cool. And then everything else after that will be a birds of a feather kind of presentation, right? One of the things I am interested in doing is getting help on the project to either redefine it further or to continue to work on it. I think it's still interesting to work on. There's a lot of information to take out of what the Copacabana guys did in terms of how they implemented their cores and all this other stuff that would be useful for Cheap Crac. And it's still to have a bunch of people, who are all in this room who are interested, essentially put together a desk cracker that can still do it in 8.7 days or better. If we can do better, we can do better. So what are the details? Well, we started with the EFF code, and that was just an economic decision, right? It's cheap to start, it's freely available, and we know it's there. We can get it, and we can just plug it in and use it, right? But we also understand that it is built essentially for 8-year-old technology, and it is built for ASICs, not FPGAs. So they don't really have a constraint quite so much about the number of logic elements. They can just write a hardware design, right? And then they'll just end up with what they have. So the issue was that when you try to apply it to FPGAs, you ran into these serious resource overuses. In the FPGA design universe, when you use too many of a resource, it's called a resource overuse. And essentially it means that you have to refactor your design to use only the amount of resources that are available on the chip. The simple design, it works fairly well. We know it works because it actually did crack DES in 2 days, but it needs tailoring to FPGAs. The University of Leuven in Belgium has a really fancy implementation that I really want, and it's actually the same thing that the Copacabana guys used. It's that 4 DES core, pipeline DES core in one FPGA, and furthermore, I know it works on that exact FPGA that I have because that's what they're using. That's what they developed it for. Right? So it's a drop-in, badass DES core. If anybody knows anybody at the University in Belgium, have them get in touch with me. What is the target performance for cheap crack? Well, I mean, we're going for the same thing that the Copacabana guys did, because really, if we can achieve the same performance with the same FPGA, we should be able to, right? The target is around to be able to crack 400 million keys a second at around 100 megahertz, right? Which is some numbers they've also seen at that particular clock speed. The XC3S1000 has a maximum clock speed of around 300 megahertz, but you want to be careful about overclocking FPGAs because there's nothing to stop you. And what stops you is a situation called thermal runaway. And thermal runaway is basically where you've clocked it so hot that the thing melts. USB connection back to controlling PC, that's a standard thing. That's how Copacabana works. And that's why we picked the USB modules, is it's easy to plug in and go. USB is a fairly simple protocol. We don't have to do anything with Ethernet frames. And it's also like everybody has USB, so it's like not a big deal. Things that was always a design constraint was to have people, to have the $10,000 could have be gathered together, and then to have it used to buy hardware to send to people who were interested. And the idea initially was that as many people as got boards would come together at a given convention, and we would take as many people who were there and build the DES Cracker live at the con. Right? And if you had enough people and enough boards, in theory, you might actually even do better than 8.7 days. Right? You might actually do a lot better. But that was to kind of have a build fest or a flash mob kind of build effort, right? Just have everybody show up, bring their board. We all have the same, image. We have some support software, and you just go. So what are some of the to-dos for Cheap Crack still to come? Well, this is the thing I mentioned, right? The Copacabana doesn't have like a VGA output on its board, so I can't do any sweet ASCII art, which is a problem. All crypto cracking devices these days need sweet ASCII art in order to be acceptable to conference providers. So it's already on the current dev board. Notably, we don't have to stay with the current dev board. The company that I mentioned has released a series of other dev boards, some of which may be better at the same price point or slightly more expensive. It was just the one that they had at the time that was like the easiest to buy and also like the best to use. There is an Ethernet module as well, which would be cool because we could plug it in, and then if we wanted to, we could not only control it over Ethernet, which would be sweet, but we could also use it network DES Cracker, right? So of course, one of these things with an Ethernet module would not be terribly exciting because it would still take longer than you would see the packets go across. But a lot of these things network together, all cracking simultaneously, and maybe capturing and storing and caching the traffic, and not just letting it pass through transparently, and then crunching on it. If I can crack in around a couple of days or even less with a lot of them together, then actually having just a little network tab might be interesting. And if anybody's still using I mean, I used to use DESLogin way back in the day. If anybody's still using it, I mean, obviously that's one target was off the top of my head. There's tons of other things you could think about. And then a better customized DES implementation would be useful, right? I mean, I want the University of Leuven stuff, but it would also be neat to, one of the reasons we picked the EFF code in the first place was because we could learn from it, right? We'd have to learn what it all meant and then figure out how to apply it to FPGAs. The University of Leuven stuff would be closer to the environment we have right now, which means it would take less learning time, but would because they've done a lot of